Given two strings x and y, find the length of the longest common substring. For example, we could have an input x and an input y, where x is AAB and y is BAA. The longest common substring between both of these is AA, and its length is 2. So our output we would desire is 2. Okay, I'll get started now. I'll call it longest common. And as I mentioned, we have string x and string y as our inputs. Open things up. I'm going to store a bit of information here, create some variables. I'll store m as the length of x and n as the length of y. I will store max as 0, and I'll store end as 0. Semicolon, semicolon. And I will also create one matrix named ARR. It's a new array of 2D, array of integers with dimensions m+1 and n+1. Now I'll start to iterate through these strings. Our outer loop will be used to increment I, and the inner loop will be used to increment j. So what I'm going to do is, if there's a common letter that we come across between x and y, I'm going to store the value of how many common letters have occurred up to this point, and in this way we'll identify the longest common substring. If the question was just asking identify the first common substring, I would have a much different approach. So we're checking if these two elements are equivalent, and if they are, then we'll update element ij of our matrix to be the diagonal previous value plus 1. And so I'll show visually how that's going to work in a second. I'm a visual learner, so things make more sense visual to me. Else, we'll update that element as 0. And we are here. We needed to, here we needed to stop that if. And if the element we've just stored at ij is greater than max, which means that if the substring we've just if the element we've just recognized has seen a higher amount of subsequent equivalencies up to this point, then we'll update max. And we'll update end as I. So we'll know that the maximum substring we've seen up to this point is the length stored in ij, and it ends at our current ith element. So I'll close off this if. I'll close off the inner for loop here. I will close off the outer for loop. Okay. Now I could print out the substring itself. Oh, let me erase this. I could print out the substring itself, but that's not what the problem asked for. The problem asked for the length of the longest common substring. So all I'm going to do is I'm going to print out max, because that will be the length of the longest common substring. And then I'll close off this function definition. Okay, so before I walk through with these two sample arrays, let's analyze the space complexity and time complexity. Okay, so these two are, in this case, they're going to, they're going to be equivalent. So the space complexity, we're using an array of m+1 by n by 1 integers, which m+1 is dominated by m and n+1 is dominated by n. So our space complexity is big O of m times n. Likewise, in this series of nested for loops here, we're iterating over m by n elements. So our time complexity is m big O of m times n. Now, I'll walk through with this example what's happening in the code. So m is, let's just see. I'll do it as if I'm commenting here. M is going to be 3, and n is going to be 3 here. Max is 0, end is 0. Perfect. So we're creating a new array of these dimensions. So let me go ahead and draw that out for us. So n+1 here and m+1 here. I'll write out the strings to help us visualize what's happening here. Okay, and you'll notice that I began each for loop at I equals 1 and j equals 1 respectively. So we'll start here at I equals 1 and j equals 1. If the 0th element of, because I is 1, so these are 0. If the 0th element of, if both these elements match, but they don't, so else this value is assigned as 0. Array of ij, no, array of ij is currently 0, that's not greater than max, so we just increment j here. Moving on, so j is now 2. If x of 0, the 0th element of x, so a matches with 2 minus 1, the 1th element, here I'll write out up here, 0, 1, 2, can you see that? No. Okay. Now you can, 0, 1, 2, and 0, 1, 2, so we're at 0, 1 in our strings. This value gets assigned as 1 because we are taking the ijth element of ARR and updating it as 1 plus the value diagonally to its left. So this doesn't have a value, so AA makes 1. Coming over here, incrementing j, we have 1 again. So what that means is up to this point, if we're only comparing to this element, there's one common element here and one common element there. Okay, moving on to incrementing I for I equals 2 and j equals 2. No, j gets reset as 1. Okay, I equals 2. So B and A, do they match? No. So 0 gets entered. A and A, do they match? Yes, they do. 0 plus 1 is 1. Here, A and A, do they match? Yes. 1 plus 1 is 2. Oh, and down here, the first time we came across 1 is greater than 0. So max would have been updated to be value 1 and end at I. But we have another update to max, so I'll assign that. Max is now 2 and I is also 2. Because 0, 1, 2, 3. 0, 1, 2, 3. Okay. So our longest common substring so far is A. Awesome. Moving on. B and B, they do match. Nothing plus 1 is 1. A and B, they do not match. And A and B, they do not match. So what gets printed out here is the value of max, which in this case is 2, and we can just sense check ourselves. Is the longest common substring, does it have a length of 2? And that answer is yes. So we're good.